Welcome back. In this video, we will cover the set operations. Okay, like union of sets, intersection of sets, set difference, symmetric difference, complement of a set, and we will also be looking at one more case study of university. Okay, like in a university, there are students of physics, chemistry, and mathematics, and there are teachers of physics, chemistry, and mathematics. As you can see, this set x1 is x says that x is a student of physics. X2 is a set of student who study mathematics, and x3 is a set of students who study chemistry. Similarly, x4 is a set of physics teachers, x5 is a set of teacher of mathematics, and x6 is a set of teacher of chemistry. Okay, so we will take this case study, or we will take these sets as a reference to learn about the different set operations along with these sets. Anyways, let's start with the set operation. What is the operation union of sets? Let's say you have a set S1 and set S2. Then what does it mean by S1 union S2? This is how you represent union. Okay, this is the union of set means S1 union S2. Intersection of set, this is how it is written, S1 intersection S2. Okay, set difference, it is written like S1 minus S2. Symmetric difference is written as x1 symmetric difference S2. I may be wrong, I will check it later. And S1 complement is written as S bar or S bar. So what does it mean when you say S1 union S2? It means that it is also a set. Okay, let's say S is equal to S1 union S2. So S1 union S2 is also a set that has set that contains all the elements of S1 and S2. All the elements of S1 and S2. Look at this. Okay, S1 is a set of tester and S2 is a set of developer. So what will be S1 union S2? It would be right if I put this here. So S1 union S2 will be equal to what? It will be equal to Upendra Yogi, Vinod Kamlesh, Guddu, Amar. Upendra Yogi, Amar, Guddu, Sanjana, Komal, John Cena, Kumar, Vinod Kamlesh, Kumar, Vinod Kamlesh. What is the number of elements in S1? So S1 is set of testers, right? Set of testers. What is the number of elements? How many testers are there? There are 4 testers. 1, 2, 3, 4. Bhupendra Yogi, Vinod Kamlesh and Guddu. So number of elements in S1 is 4 and number of elements in S2 is Amar, Johnsina, Komal, Kumar, Sanjana. 5 is 5. So what is the number of S1 union S2? Means number of elements in S1 union S2. This is equal to, as you can see, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this is equal to 9, which is obviously 4 plus 5. 4 is from number of S1 and 5 is number of S2, which you can say it is equal to number of S1 plus number of S2. What is S1 union S2? Set of testers and developers. No. Set of testers union set of developers. This is not a correct terminology. It is not and here. Okay, remove it. Set of testers union set of developers. Union set of developers. Okay, so that is what union means. Union means that in the resultant set you are going to have all the elements that is in S1 and that is in S2. S1 union S2 means that in S it will have elements from S1 and elements from S2 both. Okay, so by definition you can say that S1 union S2 is equal to X such that X belongs to S1 or X belongs to S2. Here or is important, that's why I removed the and here. Okay, so or is important here because if X1 belongs to if X belongs to S1, it has to be a part of S1 union S2. If X belongs to S2 also, it has to be part of S1 union S2. So this is the formal definition, you can say. This is the formal definition of union of two sets. Or this is the definition of union of two sets. Definition of union of two sets. So this is one example that I have taken from the case study of the MNC. Let's take this new case study also of union, means from this university case study also. From this university case study also, let's take the union of, let's say, X1 and X2. So what is going to be in it? Whatever is in physics, all of this will be in X1 union X2, and all of this will also be in X1 union X2. So let me write it. So it's going to be Flintoff. Okay, I'm not going to use double quotes, it's taking time. It's going to be Flintoff, Peterson, Rahul, Saurabh. Flintoff, Peterson, Rahul and Saurabh. Okay. What is X2? X is a student of mathematics. That is Peterson, Jacob, Rahul, Abhishek. Peterson. Okay. Okay, I'm just writing it straight after looking at. Okay, I'm just writing it straight after looking. That does not mean that you have to maintain the order. Set is an unordered collection. Okay. Jacob. Jacob, Rahul, Abhishek. Rahul, Abhishek. Good. But this is not right. This is not right. Actually, this is not a set itself. If you see this part, this is not a set. This is not a set. Why? Because Peterson, Rahul, look at these two. Look at these two. They are duplicates. They are duplicates. Okay. So what I did while performing union of the two set, I am just taking X1, writing everything that is in X1, and taking X2, writing everything that is in X2. But it happens that that Peterson not only studies physics, Peterson is a student of mathematics too in that university. Similarly, Rahul not only studies physics, but he is a student of mathematics too. And by just randomly looking at x1 and adding all the elements of x1 and looking at x2 and randomly just adding all the elements of x2 without even thinking that there might be common elements. So there might be some students who are studying physics as well as mathematics, so they are not going to be added twice in the union. They are not going to be added twice in the union. You have to add only once. So here what I am going to say is this is very crucial, that when you are applying union of two sets, you don't count the same element twice just because they are present in both the sets. You are not going to add the same element twice. So what are you going to do? You are going to add every element only once. So Peterson is not going to be added twice. It is going to be only one time added. Flintoff, Peterson, Rahul, Saurabh. Now Jacob, Abhishek. This is x1 union x2. Okay, this is x1 union x2. So what is the number of elements in x1 union x2? So number of elements in x1 union x2 is equal to 1, 2, 3, 4, 5, 6. And number of elements in x1 is equal to 4. Number of elements in x2 is equal to 4. So in this case, you found that number of elements in S1 union S2 to be equal to number of elements in S1 plus number of elements in S2. But in this case, it is not equal to that. It is 6, but the sum of them is equal to 8. Number of elements in x1 plus number of elements in x2 is equal to 8. Okay, this is not equal to 6. The difference between that example and this example is, in that example, there were no common elements. In this example, you have Peterson, who is a physics student also and mathematics student also. Rahul, physics student also, mathematics student also. So you have some common elements between both sets. In the earlier example, in the set of testers and set of developers, there were no common example. So all the elements of S1, which is testers, have to be added, and all the elements of developers have to be added. And by adding two straight, and by adding the elements of two set, you are not counting any element twice because they are nothing common. In this case, you just cannot just directly add all the elements, because then you will be counting some elements twice, those elements that are present in both the sets. So you have to take care of that. While taking care of that, you get number of elements to be 6. Okay, so the formula for number of elements in A union B, or number of elements in S1 union S2, this is equal to number of elements in S1 plus number of elements in S2. This thing, it is true for disjoint sets. When no elements are common. Okay, but if there are any elements common, okay, then number of elements in S1 plus number of elements in S2, within this term up to this, you are counting twice those elements that are present in both S1 and S2. So what you will do, you will subtract one time the number of elements in S1 intersection S2. Okay, and so this is the overall formula. So look at this. Number of element is what? 6. So number of element in x1 is 4 and number of element in x2 is 4. The number of element in x1 plus x2 is 8. So in this 8 you are counting Peterson twice and Saurabh twice. So if you subtract 2 from this 8, now you are counting Peterson and Saurabh, Peterson and Rahul only once. So what is the number of element in x1 union x2? It is 8 minus 2 equals to 6. So this is the general formula. This is the formula for the number of elements in S1 union S2, which is equal to number of elements in S1 plus number of elements in S2 minus number of elements in S1 intersection S2. What is intersection S2? This is another set operation only, intersection of sets. What do we mean by S1 intersection S2? Means those elements, it will give you a set that has the elements that are common in S1 and S2. Okay. Now there is something called as Venn diagram. What is a Venn diagram? Venn diagram, why it is important? Or because using Venn diagram is a graphical way of set representation. That's one thing. But many properties or many laws of set, many operations of set, okay, all of them you can easily visualize using Venn diagram. Okay, you can come to that using Venn diagram. Venn diagram is, if you can just look here what it says, just look what I have written. The properties involving sets, they are actually very intuitive because it's a basic, this is just a basic set. Sets are very basic things, and any property that involves sets, they are very intuitive, they are very commonsensical. Okay, and all of these properties related with set and set operations, they can be easily visualized through Venn diagram. Okay, you will see how everything that is there in the Venn diagram so far, that can be easily visualized using Venn diagram, or you can easily prove it in your mind through Venn diagram, because most of the things is very intuitive. So let's look at some Venn diagram. Okay, let's look at Venn diagram. So any set A, as you can see, any set is a subset of universal set. So that's how you, okay, we'll cover Venn diagram part and the rest of the set operations in the next video after charging. Thank you very much.